Hello friend, today we will discuss the unit of stress and strain. Okay, actually this is the first unit of solid mechanics or strength of material. Okay, so today we will discuss this topic, and these are the list of content that five points we will cover in this video. First is the types of internal forces, then material used in construction, mechanical properties of all materials or the mechanical properties of materials, then concept of stress and the concept of strain. Okay, these 5 points we will cover in this video. So first is the types of internal forces. Okay, so basically we have three types of internal forces. Okay, so that particular internal force is totally depend on the external force acting on our particular member. Okay, so first is the tensile force, the force which acts away from the point of application called as a tensile force. Okay, so which force we called as a tensile force? If the force is acting away from the point, that particular force is called as a tensile force. Okay, then next one is a compressive force, the force which acts towards the point of application called as a compressive force. Okay, means if any force is acting towards the point of applications or acting towards the body, that particular force is called as a compressive force. Then next is the shear force. Okay, the force which acts parallel or tangential to the plane called as a shear force. Means if any force is acting parallel or tangentially on the body, that particular force is called as the shear force. Okay, so these are the forces which are acting on our body, and these are the examples of that particular force. Now if you see this first diagram, so in first image you can see the two peoples are stretching that particular wire. Okay, so if I consider any section over here, okay, so that section getting a tension. Okay, that section is subjected to a tension. Okay, because both peoples are pushing, or we can say the pulling of that particular wire. Then next one is the compressive force. Now if see this diagram, in this diagram the one box is there and two peoples are pushing that particular box. Okay, so there it means they are applying the force towards the box. Okay, so if we consider the total force system on that body or the box, the particular box is subjected to the compressive force because both peoples are compacting or compressing the or applying the force towards the box. Similarly, if we see this last diagram, third one, so in this diagram we can see the two blocks are connected by one bolt. Okay, and if you push top block towards right and bottom block towards left, okay, so some shearing action will be there. Okay, so here at this point some action will be there. Okay, that action at this point, and that action is called as the shearing action. Okay, so means at that point the this particular bolt is subjected to a shearing actions. Okay, so these are the example of shear force, tensile force, shear force and the compressive force. Now next one is the material used in construction. Okay, generally in any constructions these are the common material which are used in any type of construction or any type of project, that is cement, sand, bricks, stones, steel and concrete. Okay, so actually bricks are the optional. Okay, but all other five materials are definitely used in every structure. Then next one is the mechanical properties of material. Okay, these are the basic mechanical properties. Some more properties are there, but as per SOM consult you have to remember at least these 11 properties. Okay, the property which are related to which the behavior of material under the action of forces under the different conditions are called as the mechanical properties of the material. Okay, so mechanical properties means what? The property which are related to its behavior of material under the action of forces under the different conditions. Means any different conditions are there and that particular material is subjected to a load, Okay, so whatever the behavior of that particular material by or under the various load in various condition, okay, that particular property is called as a mechanical property of material. Okay, now these are the mechanical properties. Okay, strength, elasticity, plasticity, ductility, brittleness, malleability, resilience, hardness, fatigue, toughness, and the stiffness. One more is there, that is flexibility. Flexibility is also one of the property, mechanical property of material. Okay, so first we will discuss about the strength. Okay, it may be capacity of material to withstand a load or the ability of material to sustain the load without collapse structure. Okay, the strength is what? It is the capacity of material withstand the load or the ability of material to sustain the load. Means whatever the load carrying capacity of that particular member is called as a strength of that particular member. Okay, now here you can see this first figure is indicate that this man is pushing this particular stone. Okay, so he has that capacity to push the that particular stone. Okay, so he has that particular strength. If you consider this this second one diagram, in second one diagram, one people is pressing the pencil. Okay, so that pencil will break when we are applying the force beyond the capacity of that particular pencil. Okay, so in simple language we can say that the capacity to sustain the load without collapse the called as a strength. The maximum stress that any material will withstand before fail is called as the ultimate strength. The maximum stress that any material will withstand means whatever the maximum capacity that particular material can resist, that maximum capacity is called as a maximum strength of the member. The next one is the elasticity. The material which comes its original shape and size after removing the external load, that property of material is called as the elasticity. Elasticity means what? If you are applying some force on the body, okay, so the particular body may change their shape and size. Okay, but after removing that external force, that particular material will comes to its original shape and size. That particular property of material is called as a elasticity. Okay, now here we can see one rubber is there and one rubber is stretched by two fingers. Okay, so now if you are applying the force by this finger, okay, so rubber will stretch, but after removing that finger, okay, so rubber will comes its original shape and size. Okay, so that's why the rubber we called as a rubber having the elastic property, because it comes its original shape and size after removing the external load. Now next one is the plasticity. Actually plasticity is totally opposite to the elasticity. Okay, what happen in elasticity? When we are applying the external load, it will change their shape and size, and after removing the load, he will comes its original shape and size. But in plasticity, the material which does not comes to its original shape and size after removing the external load, okay, that particular property is called as the plasticity. Means if you apply the force on particular body, so maybe that body will change their shape and size, but after removing that particular force, he does not comes to its original shape and size. Okay, then next one is the ductility. It is a property of material to under the considerable deformations under the mention before rupture. Okay, ductility is what? It is the property of material to undergo the considerable deformations. Means if we are applying the forces on that particular body, okay, or the particular material, so that particular material will extend or will deform in some amount by when we are applying the external force on that particular member. Okay, once if if continuously we are applying the force on that particular material, and once he complete the capacity of that particular material, so that material will collapse or fracture. The next one is the brittleness. It is the property of fracturing a material without warning or without appreciable deformations. Okay, so actually ductility and brittleness, these are the opposite properties to each other. Okay, in ductility he will deform first and then he will break, but in brittleness he will not deform, he will directly fracture or directly break when he ends his maximum capacity. Okay, so now in this diagram we can see, if we consider the any one chocolate, and if we apply the load on that chocolate, so without deforming that particular chocolate will break. Okay, so malleability, it is the property of material by virtue of which it gets permanently deformed by a compression without rupture. Okay, malleability, what malleability means, what if you are applying the some forces on the body, okay, so that body will permanently deform by the compression without rupture. The next one is the resilience. Resilience is here the system's ability to observe the disturbances before it change the variables and the processes that control behavior. Resilience is the ability of an elastic material such as the rubber or animal tissues to absorb the energy such as from a below and release that energy at its spring back to its original shape. Okay, in simple language you can say the resilience, what it is the total or the maximum energy that can be absorbed by the material. That particular property is called as a resilience. I repeat, the total capacity absorbed by the material, that energy absorbed by the material is called as a resilience. Okay, then hardness, the resistance of the material to scratch, wear or the penetration of its surface by a hardened bodies. Okay, hardness means what, it is the resistance offered to the scratch or wear and tear in action and the penetration of the surface. Okay, now here we can see, if we see first diagram, in first diagram or in first image we can see one glass is there, and in on that particular glass we are scratching that glass by using some external material. But now here in another image we are considering one iron material, and that iron material we have scratch by using same material. Okay, so now if we compare this glass and the iron material, so some scratches are occurs in glass when we compare with the iron, because the hardness capacity is less of glass as compared to iron. Okay, so next one is the fatigue, the highest stress that a material can withstand for a given number of cycles without breaking, called as a fatigue. Okay, highest stress that a material can withstand means maximum stress, or in the maximum stress that material can sustain that particular stress, okay, in the number of cycle, that particular property is called as a fatigue. Next one is the toughness, the amount of energy that a material absorbs before its fracture. Okay, so total amount of energy absorbed by the material before the fracture, that particular property is called as a toughness. Stiffness, the ability of material to resist the elastic deformation is called as a stiffness. The ability of material to resist the elastic deformation means, if we are applying the forces on that particular material, and if that material will extend or will deform, okay, so whatever the resistance offered to that particular deformation is called as a stiffness. Okay, so these are the basic properties. Okay, then next one is the concept of stress. Okay, now see, first of all we will see the definition of stress. The force of resistance offered by a body against the deformation or the internal resisting force of a body is called as a stress. Okay, actually stress have two definition. First is the force of resistance offered by a body against the deformation. Means if you are considering any force, any body, and if you are applying the force on that particular body, okay, so whatever the resistance offered by the member to the external force, that resistance is called as a stress. And in another word, we can say that the internal resisting force of a body is called as a stress, and that particular stress is denoted by sigma. Okay, this is a symbol of stress. The mathematically, the stress is defined as the force, that is the reaction per unit cross sectional area, and the SI unit is Newton per meter square, or you can say as a Pascal. Now here we can see one diagram is there, one member. Okay, on that member we are considering the tensile force. Okay, so due to the tensile force, what happen, this member will elongate. Okay, so whatever the resistance offered by that member, okay, offer from that member to resist the deformation, that particular force or the stress is called as a stress, or that particular force is called as a stress. And mathematically the stress is defined as R by A, where if you consider this, where R is the reaction, and if you consider this diagram, okay, so reaction is equals to this force, so we can conclude that stress equals to P by A. Okay, so next one is the unit conversion for the stress. Okay, as we discussed in last slide, unit of stress is Pascal. So 1 Pascal equals to 1 Newton per meter square. The second one is the kilopascal. Okay, so now we know that the kilo to Newton, we know that one relation, that is 1 kilonewton is equals to 10 to the power 3 Newton. Okay, similarly if we consider the 1 kilopascal, so it is 10 to the power 3 Pascal. Okay, so for 10 to the power 3, where Pascal is Newton per meter square, and if we convert this Newton in kilonewton, so it will convert kilonewton per meter square. Okay, now after that megapascal. Okay, so megapascal is a 10 to the power 6 Pascal. Okay, megapascal is 10 to the power 6 Pascal, and 1 Pascal is what, Newton per meter square. Okay, so 1 megapascal we can write 10 to the power 6 Newton per mm square, but if we convert in Newton per mm square, okay, so 10 to the power 6 is there, and if we convert meter square to mm square, so meter square is equals to 10 to the power 6 mm square. These sign conventions are there. Okay, so meter square is equals to 10 to the power 6 mm square. For the sign conventions, please refer my previous video. I have explained the sign conventions for the length, area, volume, energy. Okay, so basic things I have covered in my last video, so please go through last video, so you will cover that unit conversion. Okay, so 10 to the power 6 get cancelled, so remaining is Newton per mm square. So we can directly conclude that 1 megapascal is equals to 1 Newton per mm square, like that. Okay, now next one is the gigapascal. So 1 gigapascal is equals to 10 to the power 9 Pascal, that is 10 to the power 9 Newton per meter square. And if we convert this meter square to mm square, so we have to multiply, divided by 10 to the power 6. So 10 to the power 9 by 6, 10 to the power 6, so it will be 10 to the power 3. And if we convert this Newton to kilonewton, so we have to multiply by 10 to the power minus 3. So 10 to the power 3 into 10 to the power minus 3, it will be kilonewton per mm square. Or finally you can conclude that the 1 gigapascal is equals to 1 kilonewton per mm square. Remember these units. These units is important for numerical, okay, or the numerical point of view. So now after that, we will discuss the types of stresses. Okay, so as per the forces acting on your body, okay, so these are the type of stresses. First is the tensile stress, second is the compressive stress, and third is the shear stress. Okay, actually stress produced in the body or the resistance offered by the body is totally depend on the external force acting on our body. Okay, if any tensile force is there, so due to that tensile force the tensile stresses are produced. Similarly for the compressive stress and the shear stress. So first we will see the tensile stress. Okay, when the resistance offered by a section of a member is against the increasing length, that section is subjected to the tensile stress. Tensile stress, how you consider the tensile stress? If any, first of all, if any member is subjected to the tensile force, and due to that force whatever stress are produced in that particular member, that stress we can call as a tensile stress. Okay, and one more thing, if we apply the tensile force on that particular body, so obviously that member or the body will change their length, okay, or will increase their length. So whatever the resistance offered to that increase in length, that resistance also called as a tensile stress. Okay, so next one is the compressive stress. So obviously if any member subjected to the compressive force, and due to that compressive force whatever stress produced in that particular body, that stress is called as a compressive stress. Okay, or in another word we can say that when the resistance offered by a body or by the section of a member is against the decrease in length, that section is subjected to the compressive stress. Okay, means what, if we are applying the compressive force on that particular body, so obviously due to that compressive force your body or your member will reduce their length. Okay, so whatever the resistance offered to that reduction due to the internal force, okay, that force or that stress is called as a compressive stress. Okay, and the next one is the shear stress, the force of resistance acting tangentially along the surface of the section, that section is called as a shear stress. Okay, means if you are considering these two block connected by one we can say as a one block, or you can say one rod. Okay, and if you are applying the tensile force on that particular both material, so whatever action produced at that point, okay, so this is your shear action. Okay, and so whatever the resistance offered to resist the particular shear of your bolt, that stress is called as a shear stress, the force of resistance acting tangentially along the surface of the section called as a shear stress. Okay, and the last for today's video, the concept of strain. First of all we will see the definition of strain, the ratio of change in dimensions to the original dimension called as strain. Okay, now see friends, basically maximum students or near about 80 to 90% people are saying that strain is a change in length by original length. Strain is a change in length by original length, but as per my point of view this definition is wrong. Change in length by original length, this definition is wrong. Actual definition of strain is what, change in dimensions to the original dimensions. This is a proper definition of strain, change in dimensions to the original dimensions. Okay, if the external force is acting along the length, then and then you can consider the ratio of change in length to the original length is called as a strain. Means suppose if any member is there, and if that member subjected to a tensile force, okay, and that external force of the tensile force is along the length, and along the length, then and then we can call this particular strain is a change in length by original length. Okay, otherwise general definition is change in dimensions to the original dimensions. Okay, and that particular strain is denoted by the E, and it is totally unitless. Okay, so this is a formula, change in length by original length if the force is acting along the length. I remember. Okay, so types of strain, obviously the types of strain is totally depend on the force acting on that particular member. Okay, if any tensile force is there, so due to the tensile force obviously tensile strain will produce, due to compressive force compressive strain will produce, and due to shear force or the shear stress or you can say shear force. So due to that shear force, shear strain will produce in the body. Okay, so now first is the tensile stress. So now here we have seen that definition of strain is what? Change in dimensions to the original dimension. Okay, and if any member is subjected to the tensile force, so what happen? Due to that tensile force, okay, due to that tensile force, the length of member will increase. Due to that tensile force, the length of member will increase. So that's why the definition of tensile strain is what? The ratio of increasing length to the original length, called as a tensile strain. Okay, and that's why the formula is increasing length by original length, that is plus delta L by L. Why we are considering this plus? Because length is increasing. Okay, similarly if we consider the compressive force, so what happened? Due to that compressive force, the member will reduce their length. That's why our formula, we can say that the ratio of change in length to the original length. Why we are considering the change in length to the original length in both cases? Because if we see here, the force is, in both cases the force is along the length. Okay, so our formula is decrease in length by original length, so obviously length is decreasing, so we have to consider that ratio as a negative. And the last is the shear strain. Okay, so what happen? If we apply the shear strain and that body is fixed at bottom, so obviously some displacement of that body, okay, due to the tensile force, so the change in a displacement to the original displacement is called as a shear strain. Okay, so this is the definition: change in displacement to the original displacement, that is dx by x. Okay, some additional types of strains also there. Okay, these are the strains that we have considered: tensile, compressive, and the shear strain. But some additional strain we have to consider while calculating some numericals or to analyze that particular member. So one additional strain is the linear or the longitudinal strain. Okay, so linear strain means what? The ratio of change in dimensions to the original dimensions along the force, called as a linear strain. Linear strain should be there. Okay, the ratio of change in dimension to the original dimensions along the force. Okay, now here we can see, here we are applying the force along the length. We are applying this P force along the length. So whatever the ratio we are considering considering along the force, that is changing a length to the original length, that particular length is called as a linear or longitudinal strain. That particular strain is called as a linear or longitudinal strain. Okay, so as this force is the tensile force, so due to the tensile force, what happen? The strain or the length is increased. So due to that increasing length, your strain is increased. That's why we have to consider that strain as a positive strain. Okay, now next one is a lateral strain. Okay, if we consider the force is along the length, okay, and if tensile force is there, so due to that tensile force, what happen? Your length will increase. Okay, so simultaneously when your length is increasing, simultaneously your other two dimensions, means width and depth, will reduced. Okay, so the ratio of change in dimensions to the original dimensions perpendicular to the force, okay, or yes, perpendicular to the force, that strain is called as a lateral strain. And if we consider the perpendicular direction of that particular length, so width and depth are the perpendicular to the length, so whatever the strain produced in width and depth direction, that strain is called as a lateral strain. So that's why delta d by t or delta b by b we can consider as a lateral strain. And if that both values, means delta d and delta b will reduced, okay, or the dimensions in lateral dimensions in perpendicular to the length will reduce, okay, so that's why we have to consider the lateral strain is always negative. Okay, so thank you. This is the video up to the strain. In next video we will discuss the another theoretical part, okay, related to our stress strain curve. Thank you.